Okie doke. Took longer to start than I wanted, but we can at least get the full 3 hours today. Had to trim the nose hairs and shit. Used it on my ears too, just to try. Getting old now, yo. 25. Alright, let's go. So last time we had defining and assigning a standard array of structs. Meaning we have a standard array. So we can include some array action here. Why? Because we need standard array specifically of some type. And we could create, what? Struct, what's it called? Excuse me, fruit. And maybe it has a name. It has a standard string, or it has a const standard string name. And then, well, if it's, well, yeah, but we should still be able to initialize it, right? And then there's a name that's unchangeable. It has a seeds amount. It also has double mass. And then sure, we could have a standard array of type what? Fruit. Or we could say standard array called fruits. And we could give it some oh, you fucker. We could give it some temporaries. So we could say there's one fruit and it's given the name apple. And it has, or this could be, well, fruits have seeds by definitions. How many seeds are in an apple? I don't know, 10. And then what's the mass? Maybe 0.3 kilos. And then another fruit, and it's called orange, and it has less seeds, maybe like 8 if you're unlucky. And then 0.4, maybe it's a big ass orange. But we need a final end brace to stop to finish up the aggregate initialization, and then sure, we could go and overload the input or the output operator. Sorry, overload the insertion operator for standard character output to then output a fruit when we're printing it, and then we could also make another one that if it's printing an array, it automatically loops through the array. Or we could just call a function that loops through the array and prints it as is. Oh shit, there's a lot of like little micro hairs on my nose. Thought I got them all away, or got them all out, but I guess not. My nose will be annoying for a day or two, but it should be good. Alright. Yep, so we could create a standard array of houses. So we could say, hey, we created a standard array of some type of house, or some number of houses. What are they? Houses? How many? Some number, whatever. It's known at compile time. And then we could say, hey, we're going to then assign those values. And it's not a const expression standard array, so we could change them. So we could have like, I don't know, like a villager in Minecraft or something. One that you can shop with. Maybe it has the same amount of items forever, but the items in their tiers go up over time. And then when you call refresh items every day when the villager gets new items, you could pass in the villager's tier. So you could have a villager that has a tier, and the villager has a standard array that it's holding of items. And then when you call the refresh function, it passes in the implicit object because it's a member function. Villager.refresh inventory, which uses the villager's tier and pulls from different lists of values. So they have higher tier items and they're more expensive, but they're more valuable, something like that. Okay, we have a struct. Cool, we created an array of structs, and then we could do a for each loop to go through every element without having to index them explicitly, without having to index them, and then we could output them. So we could say, hey, house number, whatever the number is, or in this case, house number, it has a number, so we could say, hey, there's a house 13, there's a house 13 has 1 story, whereas 15 has 2, 14 has 5 rooms per story, and fucking number 13 is a mansion. We print the information for each one, sure. Okie doker. Yeah, so we had defining and assigning or just initializing. So we could do two ways. We could have one house that's created, another house that's created, another house that's created. And then we could just create the standard array and pass in those house identifiers. Or we could do what I did where we just created different temporaries whose values are assigned to the elements. Oh, true. I guess you could assign it like that, huh? Maybe that makes it more readable. Okay. So I'll do a standard array of gun. Okay. Let's say we need array. What else do we need? Sure, we'll do string for a name. Standard string. Need standard array. Okay. What we're gonna do is we're gonna say class gun. What does it have? It has a standard string. It has a const standard string name because you can't rename the gun. It has int current rounds, sure, and maybe there's a maximum magazine size it can ever have. So we'll say int max rounds, or maybe that's the max of the current mag size, and we could say, and then we could have like an enum gun safety, and then we could say safe semi auto burst. Oh fuck, automatic. Sure, we'll say. And then we could say it has a gun safety, and whatever. That's there, and that's changeable. And so we could have, what were we even doing? I don't even remember. Oh, we could say there's a const expression gun, well, standard array of some type, whatever. We'll just say standard array guns. What are you complaining about, son? All right, and then we'll say gun, and it has its AK-47. Sure, we'll say it has 17 rounds in it. We'll say the max is a 25 round mag, and then we'll say safety right now is automatic. Oops. Okay, what is the issue? Oh, here. So we have a standard array. Oh, guns, and it is initialized with this gun. What is happening here? No instance of gun matches the arguments? Are you sure, bucko? Oh, wait. Well, the string didn't matter, huh? Oh, no, it's having a big issue. Oh, it can't be const expression because there's a standard string in it, huh? Hold. What is happening here? Let's go back to regular syntax so I can see what the hell's going on. They're saying standard array of guns. This guy. I mean, does it need the fucking type? Why not? What's happening here? Is it in namespace? Using namespace standard string literals? S? Still not the issue, huh? What if we made another? And we said this one is called P90. We'll just say AR-15. Sure. And it has 23 rounds in it. 223, nice. Say 30 and safe. Okay. What the fuck is the issue here? Am I just being a retard? It's a standard array of type gun. Or, well, with gun. Oh, well, there need to be 2 elements here. Still? Why not? So it is a standard string here. Is it because it's const? Bro, am I just really stupid right now? What is happening? Oh my god. Oh wait, no. Oh, what? I don't understand. Oh my god. Oh my god. Oh my god. Oh my god. Ay, ay, ay. This whole time I was on muscle memory. Boom! All because it was a struct. And it was saying no constructor. Motherfucker, if it has a constructor, it's not a struct. It's not an aggregate. Ay, ay, ay. If I'm using an aggregate or what I think is an aggregate and I'm getting a non-aggregate error, well, buddy, it thinks my aggregate's not an aggregate. Solution? Make my aggregate a fucking aggregate. Boom. If it's a class, these data members are all private, and we can't initialize this guy like this without a constructor. We could make it a class, and we could make gun, and it takes a const standard string reference, and this is an L value reference, so we can take an R value, which is that AK-47 string literal, and we'll call it, well, let's update these now so they're named properly. M name, M current rounds, M max rounds, M safety. That way we can say, hey, name in current round, well, current rounds, in max rounds, and gun safety, and, well, gun safety, safety. And then we can say, hey, initialize M name to be name. Initialize M current rounds to be current rounds. Initialize M max rounds to be max rounds. And lastly, M safety to be safety. Oops. Okay, now what are we complaining about? Hold. Oh, well, the problem here is that it's saying, hey, there's a function here, gun is not accessible. What does that mean, bro? It means he's not fucking public. We can't call him. It says, hey, there's something that we could use. There's a constructor. That's why it doesn't say, hey, no constructor found. We just can't use them. We're not allowed. So, boom. What happens if we try to make this constant expression, huh? Oh, okay. Okie doker. Works. Cool. It's just being stupid. So long as you're explicit about the type. Meaning an array of structs, just like, yeah, that's fine. And if we wanted to do, actually I already did that earlier. Never mind. Alright. CTAD action. Loop through them, print them. Cool. House 3, provide 3 house objects. Okay, timer is on. Let's get some music. Initialization without specifying the element type. We already know this, motherfucker. Wait, hold. We are going to learn about brace elision here, so... Excuse me. Well, yeah, because we're making temporaries here. But in the assignment case, is that right? Excuse me. Oh, well, because we're using a struct here, and we don't have an explicit constructor that disallows this. It's allowing the automatic implicit, the implicit conversion of an initializer list of 3 integers to just be a house. But if we had other definitions in the same scope, it might implicitly convert to a vector or something else, and maybe it doesn't know which to call. It knows that each element of houses is a house. Oh, so it's going to say, hey, you can implicitly convert to a house. Okay. I guess the point is for each statement here, right? It sees, hey, there's a house L value receiving a house R value via copy initialization. Well, I don't know if it's really a constructor, but if it is a constructor still, just a default one, then sure. It sees that the constructor is being called and it's non-explicit. We're assigning an R value to an L value via constructor, or via the copy constructor. But if we tried to do standard array and we didn't put house as the explicit type here, it's not able to deduce fully. This looks like magic. I don't like it. I kind of like treating every constructor like it's explicit. That way we have to say, hey, this is what's going on here. Because if we were doing this, but then we were creating a vector for the position of the house, maybe we have it in 3D space. Well, GG, which one is which? You have to look at the lines and say, oh, we're assigning to a house. Oh, we're assigning to a vector element. Even though these initializers look the same. A standard array is a struct that contains a single C-style array member. So like a const char pointer or something, somehow? Ow. So we have a type is here. So we don't know what type, well, oh, because that's the type of the element in the array. And we also don't know the size of the array. And this is the name and then the size. And elements of type n. Elements of type n. Array of that size. But instead we have t here, because t is the type, and then n as a little subscript action, but defining it, not using it. try to initialize houses above. So the point is, if a standard array is a thing with a single C-style array, says, hey, there's a standard array and it's called houses, and we're saying, hey, so it sees that there's a C-style array of type house, right? Oh, and so the point, oh, it's the same chords as I want it that way. Okay. 1317. So it's seeing, hey, there's an initializer here, bucko. What do I take? I am a struct that has one data member. One. And it is a C-style array. What is it? Oh, well, here's a C-style array, bucko. But wouldn't... But wouldn't it think that this entire thing is that C-style array? And it would think that this is element 0, 1, 2? No? Because if it thinks that that is the initializer to be the C-style array member, then 13, 1, and 7, 13 can't convert to be a house, yo. Because these guys don't have default. I guess they could have value initialized arguments. Okay, so that's the point. So the other guys can be either uninitialized or used. Well, man, I wonder what happens if. Hold on. I got a shoulder pimple. I'll be right back. Okay. There it is. It's done. Bro. I'm hearing. Oh, this is what I'm listening to? Okay. I guess it isn't most important. That's true. But wouldn't it fail, though? Because if it thinks that that one element that has multiple elements in it, or that one initializer, wouldn't it fail, though? Or maybe not. No, because... what would it say? So if we put in... include array. What the fuck am I doing? Standard array. Struct, and we call it guy, sure. And then we'll say a guy has what? He has, well, I need a name, sure. Is a const standard string name, and he has an int age, sure, right, and then an int mass. All right, and then what if we say, all right, we have a standard array. Nobody gives a shit about the type, and it's called guys. All right, and we call it with so we could say guy, Ethan. My age 25, my mass, well, we're talking kilos, like 69-ish, like 150s, and then mid like 150. Let's say 70 kg. Because that's like 154-ish. Yeah, it's about 70 now. And then boom. Okay. But now, what if we remove that? what does it see? It sees a C-style array. Well, I guess the point is it's thinking that it's going to say, is there going to say no constructor that matches? Because it's seeing, hey, you are initializing me with 3 separate elements. Instead of saying, hey, you're initializing me with 1 guy, and it is initialized with 3 elements. So I have 1 element versus I have 3 elements, right? So if we do this, see the errors? It can't deduce. Excuse me, standard array void? Is there like a function called end or something where if we remove guy, it thinks, hey, when we put in guy, it sees, hey, well, if it's a C-style array, it's going to think that the elements are each a separate guy, right? I think we just get compiler errors. So if we say guys, and we put in an extra pair of braces here, I don't know how we're supposed to format them. And then we have another one called oops. Okay. Oh, what are we seeing here? Standard array of guys. I guess that's not the answer. Did I misread? Oh, well, this doesn't make sense. I'm calling this people. People. No fucking guy named Alexandria. Oh, hell no. So there's 1 people, and there's another people. Okay. So what is the way that we can actually omit it? Say we said there's 1 initializer here in your for your C-style array, and then here's another, and here's another. The whole thing is an array of these types. If we say here, we know that we're initializing this with 1 house, but we're initializing this with a C-style array of multiple houses. So a house, and then the name, houses, and then an array of some type. And if we don't put in So is the point that we need to initialize it with 1 value in total? Well, I guess 1 value that holds multiple elements. And the problem is if we do it like this, then we're saying, don't know what this is, so this is multiple elements, and then multiple elements and multiple elements. It's different than the size. I mean, it's at least different from the size. It thinks they're not. It might think they're a 9. Single C-style array member, huh? That's what I tried to do. Maybe I did the wrong brace though. I don't think I did though. So it interprets that as the initializing for the first member. The first member of houses. Because if we're initializing houses, doesn't it think that there are multiple members though? Well, I guess not, because if houses is just a struct. Alright, hold. If we initialize houses, and houses, well, house is the struct. Houses is just an array. So if we initialize houses, trying to see the issue here. I mean, because we could do houses and do int 3, and then the houses are just the house numbers, and we could do the same syntax. And it wouldn't go, oh hey, array of length 1. Excuse me. Are you sure? Why is this? Why is it only initializing the element 0? Is it because if I say, hey, this thing has a member, one member in it, and I'm initializing that one member, it says, okay, that member is going to be this. So instead of it being passed an entire grouping of, so houses is being initialized what's in here. Well, what is houses? Houses is a struct called, well, houses, sorry, is a standard array that holds one object. And that one object needs to be assigned one value, it seems like. That holds all these different bits. The price is 700, and that includes 2 peripherals. And then you have another one that's 1,000, and it's 3 peripherals. And we would have to put these guys in additional braces. Are you capping? What do we have to say? PC 2. We do. It's not able to detect, huh? I don't know why it's calling standard array void. Okay. I guess I have to explicitly do it sometimes. We would think that class template argument deduction would happen, but I guess not. So for some reason, we can't initialize a C-style array with bop, 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 because if we do, why not? Has one data member inside the struct, which is initializable with an array. What about here? Let's find the proof. Maybe it's just a C-style thing. Oh! It fucking works. And if we have a standard array object that holds one C-style array, it doesn't like seeing brace, brace, comma, brace, brace, comma, brace, brace. I guess the C-style array uses the first brace, brace. Let's confirm. I'm gonna make a C-style array and probably fuck it up, but we'll find out with what we know now. Tired of this music? Let's do this. Can we shuffle? Oh, GG. Let's just make a class. Test has whatever. Double % correct. Or we could say questions and double questions correct. And we could say that we have a test. Tests. And it's initialized with test one, or well, it has 20 questions and 17 correct. Hold. Motherfucker, I did class again instead of struct. Okay. But now, what if we do this? Still okay. But now, what if we do this? Still works. Hold. We have another one that's 50 questions, and you got 38 correct. Is the reason because... Does it look like this? Where we have standard array, x, and it is getting this value, and it contains inside it a C-style array. So this standard array is getting this whole thing. But what's the C-style array getting? It's getting this whole thing. So if our syntax is 20 questions, 19 correct, and then 50 questions, and then 38 correct. Excuse me, the standard array is getting this whole value, but then we're initializing this C-style array with this, meaning there's no all-encompassing guy to say, hey, C-style array, you're getting this whole thing that has two elements in it. Instead, it's C-style array, you're getting this. Not this, not this, but this. It feels like it's almost saying C-style array is this guy. 2019. And then what? Probably 50, 38. And if this is the case, it's saying, hey, this guy's evaluate, or, well, it's either, oh, I wanted that high note. It's either this is evaluating to this guy, and then this is being assigned this and evaluates to this guy, or it's this guy assigned this, and then we get this guy and this guy, which the left gets is returned in the comma operator. Regardless, which one is this C-style array getting? So for example, if we say a test tests, and it is initialized with that, what is it getting? What do we say? 10 questions, you got 9 correct, and then 20 questions and you got 19 correct. Well, which one, motherfucker? Which one? It doesn't know. It's saying, if we get rid of this, we're doing copy list initialization. But now, which one is it getting here? It seems like it just doesn't like it at all. Okay. And it seems like that's what's happening whenever we're doing well, do we even need this? Oh, sure. I'll say 2. And so test is getting this, and the member is being initialized with what's in here. Instead of getting initialized with one thing and another thing, it's getting initialized with both things that are in here. And then it looks like this, but it looks nicer if we do this. Like that. And now we can say 2019, 50, 48, boom. boom, now we're cool. But all of a sudden, it's the same error as before where it's sent, well, I guess not literally, but this C style is being initialized this guy. Which fucking one, huh? I think this makes sense. Okay. And now what if we remove that? Oh, and maybe it's because what type would it even think that it could be? Because it might think that it's a C style of integers because it's a C style being initialized two separate brace things. Jesus, hold. Two separate brace guys and one with two numbers. Well, if we have the comma, that evaluates to the left number, and we have another brace guy and a comma, and it's evaluates to the left guy, and then they both evaluate to one guy. It's an integer. Or it's the other guy, it's the struct. But I don't think that's actually the issue. It's not an ambiguous one because, well, it's not an ambiguous match. I don't think it is. Can't deduce for size. Okay. As the initializer for the first member of houses, but then, and the rest will be zeroed because it sees that it's a C style of 3, but it only sees the 1. Pimple on the back, little one. Ow. Then compile will. Okay. So we add an extra guy. Add an extra set of braces. They are required to initialize the C style array inside. Okay. Standard array initialized with an extra set where the element type requires a list of values. And, well, yeah, I mean, if we're not doing 1, and, well, yeah. Meaning that if the element type is a multi-member guy, like a struct or an array itself, and we're also omitting the type. So otherwise we don't need to. And why does it not need it if we are specifying the types already? I guess the compiler's just cleaning it up. Okay. Here it is. Ow. When initializing it with a struct, class, or array, so something that takes multiple values in it, that we're doing with list initialization probably. Need the extra pair if we're not specifying explicitly. An artifact, okay. And it's because a C-style array doesn't use a list constructor. So we have to pass it an entire item. But it almost seems like it is using a list constructor if we're specifying the separate guys. Huh. I don't know. Champy? Which one is this? Oh, okay, it's a good Pokemon. Say struct house, it has 3 things. We do this guy. Well, we could do double braces like that. I mean, I guess we'd do that. And then printing each one, okay. Like, in that case, we have single braces. It seems like it's saying, hey, this whole array is being initialized with this. And the C-style array inside that does not use list initialization or a list constructor is initialized with this. Well, which one? Does it evaluate to the left one automatically because left, 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 1? No, it actually does get all 5. So, how? So we could do this, but aggregates are nice. They have brace elision, and so in some cases, we can actually remove the extra braces. And I wonder why that is. Does it call a different constructor? Does it change the constructor? Is there a condition in the constructor? I don't know. You can omit them when each element is not a list of values, huh? Or when they're explicitly named because those are independent values, I guess. So it seems like it doesn't like matrices. It doesn't like matrices that are 2D, really. I mean, I guess it's 2D technically, but not a matrix with an x of 2 or more. It doesn't. Ow! It doesn't like that. Basically, it says, hey, index 0, or well, index 0, 1, 2, 3. It likes, okay, 0, 1, or 0, 0, 0, 1, 0, 2. It doesn't like 0 something and another, meaning, like, I mean, I just draw it out just so I can articulate it better. It likes, or I guess matrices like this, right? It likes seeing value, 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 and says, hey, this is the 0th element, this is the 1st element, this is the 2nd element. So, even if it's 1, if the value is 72 and 6 and 4, that's 1 or 0, 1 and 2. Cool, to initialize the C style. But, excuse me, if it is 7 and 3 and then 4 and 4, because it's going to say, I see 2 things here. There are 2. And then there are 2. So what does this mean? Is this 0, 1, 2, 3? What is happening here? Is this 0, 1? Or is this 0 and this is 1? That, yes. But the only reason it actually figures this out is if we say the name. We say the name, and then it becomes 1 value. So it's the first value and the second value. It doesn't like assigning separate pieces. So like saying, hey, C style, there's no S in there, is value, value, value. So if this is multiple values, this one has multiple values, this one is multiple value, this one is multiple value too, then it doesn't know. Is it 1, 2, 3? Is it 0, 1, 2, 3, 4, 5? What is it? Really, we need to package them together. And now they're just faces. Oh, great. Okay. So we can omit it when we're giving it single values, because when it takes a class type or array and we explicitly name it, we say, hey, convert to this value. It is a house. It is not two separate values. It is a house that happens to have two separate values. We could always do double, or try to single brace initially, or start with single braces, and the compiler will bitch and moan if it doesn't like it. Another example where we do it with student structs. So we could do bop bop, or we could do it's bop 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 bop, and then we could have separate values like that. That way it's still saying, hey, it's one piece. Or it is separate value, value, value with the type specified explicitly. So we say, hey, we have a type of student as an ID and a name. Okie doke. We have a global array. Nasty, yo. Nasty, nasty. Students. And it has student, student, student. And then we have returning a pointer to a student. So it's returning where it is in our little list that we have. So the teacher's attendance sheet, or the school database, where everyone has his or her ID. And we are finding a pointer to each the elements in these standard arrays. Honestly, I haven't returned a pointer in a minute. Returning by address, yo. We can loop through each one. So the point here is what? Find the ID, and we pass the ID so that we have IDs 0, 1, and 2, right? And the point is, oh, we pass in 0. Find the student. Which one has the value? Oh, return. Well, so for each one, we check each one's ID, and if it matches, then we could return that. So we could say, like, yeah, that'll work. We could do something similar. I kind of want some depressing stuff a little bit. I'm no wimp, but there's a band I'm kind of partial to. Yeah. This one's always good. Let's do this one. Oops. So we're going to say include some array action. And then we're going to say, what do we want? I need vending machine, and then we could say vending machine, and for each thing in the vending machine. Yeah, okay, that could work. So we could say struct drink, and we could say include standard, well, string view. We have these drinks, right? And each one has a standard string view. Well, let's just make it a const standard string view. Changes nothing, I think, but standard string view, we at least can't try and change it. I mean, it's read only, but we can still try and affect it. I guess this means it's just not reseatable. Standard string view, and it's called name. And then we'll say, I mean, I guess it's brand, right? We could do brand. And then int price. Well, we'll say double price, sure. And then we could say standard array of, well, what type? We could say drink 3. Or we could say standard array, well, I guess, well, let's find out. Standard array vending machine. And it has drink Dr. Pepper, and the price is $2.34. Oops, $2.34. Okay, so it's happy with that. But if we omit it, what if we omit it and then we put in, even then it still needs to know the type. So it could go bop bop and then give it the type, and it's, well, yeah, sure. And we could say drink and there's 1. Okay. But then if we put in another and we say, well, what's another good drink? We'll just say, well, let's say Minute Maid, something like that. I think it's spelled weird like that. And it costs $3.30, because of course it would. And now it has an issue. Why? Because it sees a C-style array being initialized with multi-value elements that aren't as part of one large group. So what we do is we go bop, bop. Oh, and this needs to be 2 now because we need the correct amount of arguments. And so we could say something ridiculous like that. Or we could do this. This. How would we actually type this out? Let's say we have, I mean, do I do that? And then this. And then we say Dr. Pepper, $2.39, sure. And then Minute Maid, $3.30. And then this. I mean, it kind of reads like shit. I honestly prefer it like this almost. And if we did that, that, I mean, that's horrid. 5 fucking lines? Oh, nah. I'm doing 1. Screw it. And then we say, return a pointer to a drink. So we do return a drink pointer, a pointer to a drink called get drink from machine. We could do a couple different things. We could say, because these are separate objects, right? And each one of these has multi-objects in it. So we could say get price, get drink price from machine, from vending machine, from vending, and then we take in a standard, standard string view name, and then we say for const auto reference drink vending machine if drinks brand is name return, and we could have it actually nested like this. Right? And then we'll just return, right, the address of the name. Hold. And this isn't a pointer. This is actually returning a... Oh, hold. This is not returning the name, duh. This is returning the address of return drink dot price. And what are we returning? We're returning a pointer to an int. And really, it needs to return this by address, right? Hold. Or hold. Oh, sorry, this is not an int. This is a double. Whoopsie. Hold. Still? Hold. It's a double. And we're returning a pointer to a double? No? Am I tripping? What am I tripping about? We could also make this const expression. Oh no, because it's a standard string view, but standard string. Cannot convert a const double? Oh, because this is return an unchangeable pointer. I understand. And then we could say, oh, well, doesn't have to match, huh? I mean, we could do a standard optional, and then we could say if found. Oh, and then if it isn't found, it returns null pointer. And then we could say we could say double my drink. Well, we could say, yeah, sure. Double my drink price. Well, we could say a pointer to it. A pointer to a double called my drink price. And maybe we say P because it's a pointer. And then we could say get drink price from vending. And what are we passing in? I want a Dr. Pepper. Okay. Hold. Line 27 is the issue? Hold. Oh, because this guy, we're converting, yeah, the first part didn't matter. We're converting from, the error here was shit. It's unused, it's fine. The point is that we were getting a pointer that we're treating as, pointing to a non-modifiable object, an immutable object, as modifiable. Because we're converting a const double to a double. Well, that means that I could change it here when we shouldn't be able to, because it's treated as const. We shouldn't be able to change it. It should be immutable. Right? And now we could say if find my drink's price, and then we could say if my drink price P is found, if drink is found, my drink's price is my drink price is P. And then otherwise, fucking machine doesn't have my drink. Something like that. Hey, we found Dr. Pepper. What about Coke? Oops. Unbelievable. And then anything else? And really what we should do is make this not const, and then we could change this. That way we could actually set that value if we wanted to and update the array and then change it. Because if we have a pointer to it, we could change the pointer and then say, hey, my drink's now empty. But really, we're still pointing to a place in a vending machine, so it's not really great. In this case, we're returning, oh, it is same implementation. Cool. Returning no pointer. Excuse me. Because otherwise, we don't always return something. Because if we say if not this, well, what are we returning by? Because we're not returning by the address of S. So we're looping through each student, checking for the ID, and then returning the address of the name. Or actually, sorry, we're actually just returning the address of the student, not even the full drink. So in this case, we're returning a pointer to a student, yeah. So well, I removed the const here. And same here. So that's fine. But that's not fine. The array can be const expression, which means that these are known at compile time, but they're also, these are C-style strings. They aren't string views there. And I bet you if we make this const, and then we just say up here, I mean, doesn't matter. It's not within a function. Well, sure. I mean, add it as late as possible, maybe. Using namespace, standard string literals, or string view literals. And then we say SV and SV. Uh-oh. It still works. I can't. Don't ask me why. I don't know. Because a standard string here can't be, well, not even a standard string view can't even be used. Oh, scared me. I heard a note that was the same as my alarm. That note. It's a C. I have no idea. And so we're comparing the ID. We're returning a student. I guess we're not here, huh? Students, however, have string views though. So I mean, can't these not evaluate the compile time? Right? What's the error here? What? This doesn't even work. Oh, hold. It can't return from const. But if we add in const expression, oh, a const expression const student, huh? Oh, It can be. I was just, when I put in const expression is referring to the function, not the student. Fucking duh. And so in this case, he's saying getting a pointer to a student, and a student has a member variable or a data member. So we do student and then pointer, well, the arrow operator to get the data member. Okay, we actually have a pointer. So we're saying, hey, we have a student, find a student, find the student whose ID is 1, find the one whose ID is 3, and then we say, oh, okay, there's the check for validity. Good, I was worried for a sec. All these little tiny hairs. And we have him, and we get his name, or we return nothing, and we don't evaluate him because there's no pointer. Because standard array student is const expression, hold, must return a constant pointer. Yeah, makes sense, because we can't make it, we can't violate the immutability of the object. Well, yeah, because this guy has const objects, which means these objects are being treated, well, const objects meaning students, which means these students are treated as const, which means these guys are also unchangeable, which means, one, a pointer to this guy means we can't change them. It has to be const, and also a pointer to this guy, same shit. And it's a const something pointer, not necessarily a pointer to const, which is why this is not student pointer const, it's const student pointer. Define a struct named item that has 2 members. Gold. Oh, an item? Oh, and it's the value and it's the name and it's worth in gold? I like this. Fuck, I didn't include string view. Well, I'll try and do it, I think. Standard string view name. I'm hoping it didn't autofill with something bullshit. And then semicolon, next, and then we'll say int gold, value initialize this guy, go to the very top, go to the end, enter, might have an extra space. Now we can include string view and say why. Fuck. Need standard. Oh, that's pretty close. Need standard string view. Need standard array. I did that pretty good, eyes closed. Hit main, what are we doing? We have an item that has a name and some gold amount. Define a standard array and initialize it with 4 items. Okie doke. And we'll call it my pockets. We'll call it standard array player pockets. And it takes a bunch of items. You guessed it. And we're going to say bop, bop. Oh, this is trash. I don't like that at all. So we're going to say this. Uh-oh, why does it do that? I really don't. I'm not a fan. So what if we do this, and then we do this, and this? Why does it do that? I don't like that very much. I'd rather just do double, honestly. This, and then this. And then we'll say it has twig, and it's worth 0 gold. And it has, I might be missing something here. And it has, well, what's happening here actually? Let's find out. Hold. Oh, well, 1, there's no semicolon. That's fun. Oh, and 2, if we're going to do this, we need to say the type. So we're going to say item and 4, which means it doesn't have enough. In this case, it's going to default or value initialize them, I guess, right? And then we'll say, okay, maybe let's just find how we're going to type this out. We say player pockets initialize with what? Okay, I don't like that. Maybe this is okay, actually. We'll say twig, 0 gold, and then ruby, 300 gold, and then rock, 0 gold as well. And then, what else do we have? Wallet, and it's worth 1 gold, sure. I don't dislike that. I think that's okay syntax. And then what are we doing with it? Are we printing them? We have a, okay, sure, we have some pockets. We use class template argument deduction to deduce the element type and the array size. Well, I mean, if we're using class template argument deduction, we're not going to do it this way. And it seems like we're going to do the redundant shit now. Item, 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 and item. Oh, oops, there it is. Oh, and I put that in the wrong spot. So, I mean, we could do it this way. I say, hey, we're creating a standard array, and it's a class and it has a C style. What? C style of some type T, a C style of some size N. Okay, and we're not specifying item. We're not specifying type. We're not specifying element type or count in the standard array. I think the 3 strats, right, are either assigning each index piece by piece, which is retarded, or in this context, or we could do the whole thing by giving it temporaries. We could create the individual items first. We could say namespace items and then make item this, item this, item this, item this. Or we could do it like this and specify the explicit types. That way, our C-style boy is happy because he's receiving an array of single element guys, not an array of multi-element guys. If it was getting that, then we would need to go bop and item 4 bop. But I don't like that very much, so I'd rather just say this, something like that. I don't dislike that. But again, in this case, we're doing item. We're doing redundancy, baby. Item, I should start from the right. Item, bop, bop, and bop. And we're going to do void print inventory, or print inventory. And what does it take? A const standard string of, we could just say a template type name T, and standard size T. What was it? We didn't want to do integer here for some reason. We'll do size T, sure. Standard size T size. Or, oh, we could do auto size. Auto size. Oops, this is standard array of T. We don't know what's holding. We also don't know the size. Array. Or items. This is the wrong operator. This needs to be a reference, so we're passing by reference and not by value like a dumbass. And then we'll do for. We don't have IOStream yet. We need it. IOStream because we need standard character output. And for what? Well, a const auto reference, so we don't care about what the value is. In this case, they're just, well, we don't care because it's going to be deduced. And we'll say item and items. And we're going to say output. Well, may as well make this be multi-lines. We'll say output. Well, item, well, in this case, I mean, item.name, if it has it, and now this is only going to be called by things that are valid, but what if we say item.x? Same thing, it's fine. It doesn't know if it's valid or not, so it can't check. Especially because there aren't calls to it yet. But we could say, item.name is worth item gold. And we can remove that so it's not nested for without reason. And then we could say print inventory, player pockets. Sure. And can't make this const expression. And we're good. Biggest word 0, 0 what? 0 gold. Oh, and we could consolidate. Boom. Cool. We have a template. Oh, and in this case, oh, true. That is true. So that way, if we know that it's item, we can at least use these guys in a valid way. So maybe we don't know the size of the inventory, but we know that inventories are going to have items. So we could say item.name, hold, item dot, oh, it doesn't even like that? Really? Item dot, interesting. Oh, because of auto? I mean, we could say const item so that it only accepts an item, sure. Item dot, and now it knows the type. That's the reason it's not doing it, because if item is deduced, it won't say what you can do. Output, item dot name is worth item dot gold, gold. Boom. Cool. Oh, sure. Well, what's he doing in here? So what's his syntax? He's saying, and did he do item each one like that? Yeah, he did. Okay. So what if we say boom like that? I don't like that it's doing that. Where is he putting his second? Oh, he's just not in this case. Okay. And then the point here is he's saying it's item twig 0 or twig 0, and then item dragon egg. Oh, and this should be double. Oh, and this, yep, double, and it's worth a fucking 100. And then item, and then item what? Ruby is worth 300. Well, dragon egg should be worth like 1,000, right? And then lastly, item. That's it. Sure, we could cut it short there. And then, oh, for some reason the semicolon died. Boom. And sure, we could put A. Oh. Okay. Same implementation. Or store. Upgrade it to not explicitly specify the element type for each initializer. Okay. Sure. So we could say, okay, well, we have to specify it somewhere because class template argument deduction is ass for standard arrays, at least for multi-element types. So we'll say item, and we have to fucking say how many, 3 in this case, and then we can, 1, leave it, or what we actually need to do is say add this guy, add this guy, oops, add this guy, and then remove item, remove item, remove item, bop. Oh shit, it's time. I didn't hear it. Okay. So now Item gold template. A something costs this. Sure. And he's doing it like that. And I'm doing it as close as it'll get. Excuse me, my thing auto spaces. I don't like the auto space. Can I turn that off? Well, let's find it. Let's just go and look. Let's do solution properties. Config. Actually, it might have to be solution. I think it is. Yep. C++ general language. Options. What if we do space? Code analysis. Clang tidy. Uh-oh. Lagging. Nice. VS22, remove auto space. Disable auto formatting. Options, text editor. Hold. Tools, options. Oh, I guess it is a whole thing, not just a solution. Tools. Text templating. Unreal. Oh. F#. Text editor. Oh, it's totally not alphabetical, but okay. General. I just don't want the spaces. Automatically surround sections when doing that. I like that. I like current line. Line spacing. Tab space. Show editing context. Advanced. What if I did that? No? View white space. Uh-oh. Alright, so what if we did, oh shit, here it is. I kinda don't dislike it. Is brace pair colorization commonly used in VS22? Okay. Yeah, honestly, I don't dislike it. Between double braces. Formatting general. Okay. View zero with view bidirectional. Automatically indent when word wrap is enabled. Surround sections. Highlight current line. I don't see it here. Okay, I think it's fine. Yep, if we're not specifying, we need to say, yo, convert to this. Because isn't there a world where these evaluate to the left-hand operands and then it gets funky? I don't know. Just depends on if assignment or if brace initialization operator is higher in the precedence order. Oh shit, I get full time, huh? Or oh, I get 30 minutes as break and then hour and a half and that's it. So no extra. Okay. So I only get the hour and a half. All right. And then we'll go next. Reference wrapper. Okay. Don't know what that is. That's it for now.